Hello everyone, good morning all. Hope all of you are well. Welcome to my channel Ali Circle Chemistry Class for All. Today I am going to discuss some problem which is already discussed in previous classes, which is related to hydrocarbons, that is interconversion between hydrocarbons. Mainly we focused the interconversion between alkanes to another alkanes, that is higher to lower, lower to higher, vice versa. So I am going to start now. First one, very simple. I'm always start from simple, and then I will give some examples of typical type problems. Ethane to ethylene. Ethane to ethylene. So write down the structure. Ethane CH3 to ethylene CH2 double bond CH2. So here the conversion is from alkane to alkene. So how can you convert an alkane to alkene? So we have to prepare alkyl chloride from this alkane or alkyl bromide from this alkane, and after that elimination reaction, elimination reaction. Very simple and two-step process. So let us try to find out this. We know, all of you know, this reaction is called bromination reaction. So if you treat ethane in presence of bromine H, we will get ethyl bromide. So from ethyl bromide we can easily prepare or you can easily convert ethylene. So this is very simple. We know the reason for conversion of ethylene, ethyl bromide to ethylene is sodium hydroxide ethanol, NaOH in ethanol. So this reaction is called E2 elimination. All of you know this. So how easy is that? Ethane to ethyl bromide, which can be converted by using bromine H2. This is a free radical reaction, free radical alkylations of alkane, and after that we can convert ethyl bromide to ethylene by a simple reagent, which is sodium hydroxide ethanol, and the reaction is called E2 elimination reaction. Now I am going to move second examples. Which is reverse. All of you know. Number 2, ethylene to ethane. Just reverse from our previous examples. Previous example we have done ethane to ethylene. Now we are going to do ethylene to ethane. This is very simple, one-step process. Ethylene to ethane, CH3. So here the double bond is converted into single bond. So alkene, this compound is called alkene. Alkene to alkane. One double bond is reduced. All of you know this hydrogenation reaction. And then alkane can be converted into alkane by the treatment with hydrogen nickel. This is very simple. Hydrogen nickel. So this reaction is called addition reaction also, or you may call this reaction as a reduction of alkene. So the conversion of alkene to alkane can be done by using hydrogen nickel or hydrogen nickel or any other some reducing agent, and particularly this reaction is called addition reactions. This means hydrogen is added to ethylene, C double bond C, which is converted to ethane, or otherwise we can say the reaction reduction, because when we know when hydrogen is added to some compound, it is called a reduction reaction. So this is number 2. Now I move to number 3. Gradually we go to the difficult problems. So let us see till the end. Now ethane to butane. Butane. How can you convert? This is number 3. Ethane, write down the formula CH3 to butane, mean, or you may say this is also called N-butane. N-butane, the structure of N-butane is CH3, CH2, CH2, CH3. All carbon are sp3 hybridized. Here is all carbon are sp3 hybridized. So this is alkane. This is also alkane. So from lower alkane to the conversion, the type of conversion is called from lower alkane to higher alkane. Whenever we have a problem to carry out the conversion of lower alkane to higher alkane, we must know the two reactions which have been already discussed in previous classes, that is Fars reaction or Corey-House reagent or Grignard reagent. So look at the problem. The alkane is N-butane, which is symmetrical alkane. If you cut it from here, we will get two alkyl group. Both the alkyl group are same. CH3, CH2, same ethyl. So this alkane is symmetrical alkane. So we know symmetrical alkane preparation can be done by using Fars reaction. That is the very simple way for the preparation of or for the conversion of asymmetrical alkane. So we move to that point. Now to get to undergo the Fars reaction, we have to prepare some alkyl halide, that is alkyl bromide or alkyl chloride, and then sodium biether. So all of you know we can convert ethane to ethyl bromide by using bromine HNO. So it is very simple. CH3CH2, Br, compound called ethyl bromide. So you see our compound is ready, alkyl halide is ready, that is Rx is ready. So when Rx is treated with sodium in triether, we will get Rr, that is called Fars reaction. So alkyl bromide can obtain, thus to use 2Na dry ether. So these two ethyl group will these two ethyl group will add, and it will convert it to our desired alkane, which is called N-butane. So very simple 3-step process. So first we have to convert ethane to ethyl bromide, and then ethyl bromide to alkane, the desired alkane, which is called N-butane. This is called N-butane. So very simple. If you know the reaction, the conversion is the most interesting part of organic chemistry. If you know the reaction, and if you know the structure of the compound, what is given, you can done any type of conversion. Okay. Now I move to number 4 examples. Ethane to butane, and then reverse butane to ethane, that is reverse. Butane to ethane, that means higher alkane to lower alkane. What is higher alkane? Who are doing the first classes of this conversion, for those students, higher alkane means number of carbon is much more compared to another one. So here butane means 4 carbons, ethane means 2 carbons. So that's why I have written here, this is higher alkane to lower alkane type conversion. So write in the structure CH3, CH2, CH2, CH3, this is N-butane or butane. We have to convert this butane to ethane, CH3, CH3. So what we have to done, we have to break this middle bond. We have to break this middle bond so that we can reduce 4 carbon to 2 carbon. In the previous class, that is a conversion class, we have done this reaction. You may remember it. So to break this middle bond, we have to convert this portion of this compound into alkene, so that we can use ozonolysis reaction. We know when alkene is ozonolysis, the CC bond, C double bond C is breaked. So we have to convert this into alkene and between N butane to butene. So how can you convert an alkane to alkene? The same method. We have to prepare alkyl halide or typically alkyl bromide, and then use the normal A2 elimination reaction. So do it. So just use simply bromine HNO. We will get CH3, CH2, CH, Br, CH3. Okay. So this is a alkyl halide, or we can say alkyl bromide. This is alpha carbon. This is beta carbon. This is also alpha carbon. There is also a beta carbon. So we know from the Sergent rule which product will be the major product when you do the elimination reaction. The double bond will comes to this alpha beta position. This part is when double bond is come to this part, the alkene is 2-butene, which is more stable compared to 1-butene due to hyperconjugations. So use here sodium ethoxide, ethanol. So what we will get? CH3, CH double bond, CH, CH3. The compound is called 2-butene. Okay. So we have reached the target 2-butene. I am erasing this portion for your purpose. So now we have to break this bond. So all of you know, to break this break the double bond of alkene, what type of reaction we can use? That is known as ozonolysis reaction. There's another reaction also is there. So basically we have to look at the desired product. The desired converted product is ethane, which contain 2 hydrogen. So we have to break here. So just use ozonolysis reaction, O3 CCl4 zinc water. So whatever you get, we'll get acetaldehyde, CH3CH double bond O. So how can you convert this acetaldehyde to ethane? So all of you know, in previous class we have learned it. In previous conversion class we have learned it. A C double bond O, that is carbon compound, has to be converted into an alkane by using reduction. That reactions are known type of reactions. All of you know. One is very important, Clemmensen reduction. Another is WK reduction. Just all of you know these two, and other reactions we will discuss in later. So just use here Clemmensen reduction. If you used Clemmensen reduction, this carbon part will convert it into alkane. So just do it. Zinc HGX HCl. So what will you get? CH3 CH2 CH3 CH3. That is our desired product, which is known as ethane. Okay. So this is not a typical problem, not very tough. Just you have to think about it, and then you can do it easily. So whenever you are doing some conversion, it is for your purpose. Whenever you do some conversion, you just look at the initial compound, that is reactant, and the final compound, that is the final desired product. What is the difference? What is the difference? If you know the difference, where is the difference comes, then the conversion becomes very much easy for you. So for this examples, what do you see here? There is 1, 2, 3, 4 carbons, and our desired product has 2 carbon, and both are alkanes. So the conversion type is, we have to understand what is the type of the conversion. This conversion type is higher alkane to lower alkane. So to do higher alkane to lower alkane, we have to use some reactions where CC bond is breaking. CC bond breaking is occur. One of the reaction, whatever we have learned in previous class, that reaction is known as ozonolysis. So here we have used this type of reaction, that is ozonolysis reaction. Okay. Now fine, I am going to erase this. Now move to the fifth problem. I think all of you are doing well and preparing for your exam. So this is the exam time for graduations, and for class 12, for class 11. All of you are now busy your examination. So that's why I'm going to that's why I'm decided to prepare some video which will be helpful for you. That is the conversions. Okay. So some of students are very afraid about it. The conversion, they know the conversion is the most toughest things of organic chemistry. But if you know the reaction, and if you know the structure, and if you know the types of conversion, then it is the most simplest part of organic chemistry. Okay. So let's move to the next problem. Toluene to next problem. This is problem number 5. Toluene to 1,2-diphenyl ethane. So in some time you will get in examinations, the structure does not written there. A name is given, so you have to know both the things, name and structure. Okay. So toluene, all of you know the toluene. The structure of toluene is on benzene and CH3, and 1,2-diphenyl ethane. How can you write this? 1,2-diphenyl ethane. How many carbon is there? Ethane, 2 carbon. 1, 2 carbon is there. 1,2-diphenyl. So written here phenyl. Written here phenyl. That is 1,2-diphenyl system, and remain valencies filled up by hydrogen. So what we have to convert? That is, again I am writing this toluene to, if you summarize this, if you write in another fashion, we use pH, CH2 pH. This both the components are same. If you see this both the components are same, pH, CH2 pH. So this is also a symmetrical type of alkanes. This is also a symmetrical type of aromatic alkanes. You see, if you cut it here, so two parts will get PHCH2. There is also PHCH2. So both the parts is R. If you see this R, if you call it R, and this is also R. So there is a single bond between R and R. So what is this alkane? This alkane is called a symmetrical alkane. So whenever you get some symmetrical alkane examples, so immediately you thought about the famous reaction. This is Vaz reaction. So I'll try to explain it. How can you convert this compound, that is toluene to 1,2-diphenyl ethane. Okay. Just I am erasing this, and after that I will do this. So toluene, I am going to start now. Toluene. So toluene to toluene to biphenyl pH CH2 CH2 pH biphenyl, 1,2-diphenyl ethane. So to do this, we have to prepare PHCH2 Br, that is aromatic benzylation type compound. So all of you know this is benzylic position. The benzylic position is eliminated by using NBS, very famous reason, NBS CCl4. NBS means N-bromosuccinamide. So if you use this N-bromosuccinamide or CCl4, or you can use also bromine H nu, or you can use also Cl2 H nu. These three types of reaction are very important for benzylic halogenations and allylic halogenation. So what will get? CH2 Br. If you use NBS CCl4, CH2 Br, and our starting material is ready. That is Rx is ready. So Rx is ready. So this is RR. This is RR. So what will use there? Rx is ready. We have to convert Rx to RR. So use Barge reaction. So the reaction is sodium 2Na dry ether. So you see how simple is that? Only 3-step reactions, bromination and Barge reaction. So it is very simple. The conversion is very simple. Nothing is here. All of you can do this. Just make your confidence. That's keep your confidence and try to do some more example yourselves. You made some compound. You write some compound and try itself. Try to convert that compound, your own compound, whatever you have written. Okay. Toluene to ethyl benzene. Toluene to 1,2-diphenyl ethane. Now I am going to convert number 6 examples. 6 example, ethyl benzene to propyl benzene. Ethyl benzene, that is CH2 CH3. This is called ethyl benzene. Ethyl benzene to propyl benzene. So how can you convert? Just this, and one carbon is introduced here. Just do it. So if you do the alkylation here, the problem is solved. But to do this alkylation this position, this is very difficult to do this. So first, whenever we do some whenever do some bromination or alkylation, where it is occur, this is occur in benzylic position. This position is very active compared to this position. So the reaction will occur at benzylic position. So that concept I am going to use now to make BHCH2 Br. So see how easy is that? NBS CCl4 will get CH Br CH3. NaOH ethanol CH double bond CH2. So just use anti-Markovnikov rules. HBr peroxide. What we will get? CH2 Br. Okay. Now you use CH2 Br. You can use magnesium in dry ether. MgBr, and then use CH3Cl. So what you will get? Propyl benzene. There is also another method I will discuss in next classes. So I can't do the 10 examples. I will make some other videos. For this we have to do some other videos. So I think all of you are interested now to do the conversions. So today's class I am going to end now. Thank you all for your time, for your patience, and let all of you are understanding this now. So try to do this. This is very simple part of organic chemistry and very interesting also. So to do the conversion, you have to know the chemical reactions and the starting material, difference between starting material and the final destination product. That is the two key factors for to do a conversion. Okay, thank you all. And if you like it, then subscribe my channel and share it to the students. Thank you all.